Right now, as you're watching this video, you are moving, not getting up to grab a snack later. Moving. I mean right now, this second, you're spinning around the Earth's axis at over 1,600 kilometers per hour. At the same time, the Earth is dragging you around the Sun at 107,000 kilometers per hour. And the entire solar system, the Sun, you, your phone, your bed, your ex's Instagram account is flying through the galaxy at 828,000 kilometers per hour. You didn't feel any of that, not a single bit, because you're standing on a rock that's basically a cosmic spaceship and you've been on it your entire life without a seatbelt. And that's just Tuesday, that's just existing. So today we're going on a trip. No spacesuit required. We're going to go planet by planet, moon by moon, storm by storm. And by the end of this video, you're going to look at the night sky completely differently. You're going to look at a grain of sand differently. I'm not exaggerating. Stick around for that one. It's at the end and it will mess with your head. This is the solar system. Buckle up. Or don't. There's no gravity issue here. You're fine. Let's go. Okay, quick housekeeping before we launch. And I promise this is the only boring part of the video. If you're new here, welcome. We make videos that take stuff that sounds like homework, space, science, the universe, and turn it into something that actually feels like it matters to your life. Because here's the thing, nobody tells you in school. You are not separate from space. You are space, just organized differently for a little while. Every atom in your body, the calcium in your bones, the iron in your blood, the oxygen you just breathed in was forged inside a star that exploded billions of years ago. You are, scientifically, made of dead stars wearing a hoodie. So with that in mind, let's meet the family, our solar system. 1 star, 8 planets, over 200 moons, millions of asteroids, comets, dwarf planets, and a couple of things at the edge that genuinely scare astronomers. If this is your kind of content, hit subscribe now, because honestly, by minute 30 of this video, you're gonna want to come back for the part 2 we're already planning. Okay, let's start with the absolute unit at the center of it all. Let's get one thing straight immediately. The Sun is not a big light in the sky. The Sun is a 4.5 billion-year-old nuclear bomb that has been continuously exploding for longer than life has existed on Earth. And it's been doing that non-stop every single second, since before dinosaurs. Here's the scale problem. And I mean problem because human brains genuinely cannot process this. The Sun makes up 99.86% of all the mass in the entire solar system. Everything else, Jupiter, Saturn, Earth, every planet, every moon, every asteroid, every piece of space junk, all of that combined is basically a rounding error. It's the 0.14% left over. If the Sun was the size of a basketball, Earth would be the size of a grain of sand, sitting about 28 meters away. Jupiter, the big planet, would be a marble. The Sun would still dwarf it. You could fit 1.3 million Earths inside the Sun. Not in a squeeze them in way, like comfortably, with room to spare like a beach ball full of grains of sand. So what actually is it? The Sun is a massive ball of hydrogen and helium, so dense and so hot that, at its core, it reaches 15 million degrees Celsius, and the pressure is so extreme that hydrogen atoms get smashed together so hard they fuse into helium. This process, called nuclear fusion, releases an insane amount of energy. How insane! The Sun converts about 600 million tons of hydrogen into helium every single second. Every second. And here's the part that genuinely freaks people out when they hear it for the first time. A photon, a particle of light, created at the Sun's core takes somewhere between 10,000 and 170,000 years to bounce its way out to the surface. It's getting absorbed and re-emitted over and over and over in this insane traffic jam of light, bouncing around like a pinball machine designed by a sadist. But once it finally escapes the surface, it takes that same photon only 8 minutes and 20 seconds to travel the 150 million kilometers to your eyeball. So the light hitting your face right now might have started its journey before humans had agriculture, before the pyramids, before language, and it spent all that time just trying to get out of the sun. And then once it was free, it crossed our entire planetary system in less time than it takes to watch this section of the video. Now, let's talk about something that should honestly be in more disaster movies: solar flares and coronal mass ejections. Sometimes, the sun's magnetic field gets so tangled up, it basically snaps like a rubber band and releases a burst of energy and charged particles into space. If one of these is aimed at Earth, it can mess with satellites, GPS, power grids, and create those gorgeous auroras, the northern and southern lights. But here's the scary version. In 1859, there was an event called the Carrington event, a massive solar storm that was so powerful it set telegraph machines on fire and created auroras visible near the equator. If something on that scale hit modern Earth today, with our satellites, internet, and power grids, scientists estimate it could cause trillions of dollars in damage and take months, maybe years, to fully recover from. So, yeah, the sun isn't just vibing up there, giving us a tan. It's an active, violent, ancient nuclear furnace that we are extremely lucky sits exactly 150 million kilometers away. Not too close, not too far. Scientists call this distance the Goldilocks zone. Too close and Earth's a Venus. Too far and Earth's a frozen rock. We're sitting in the one spot where liquid water, and therefore us, can exist. One more wild fact before we move on. The sun is so big that light from its core takes around 170,000 years to escape. But the entire sun itself will eventually run out of hydrogen fuel. In about 5 billion years, it'll swell into a red giant so massive it'll likely swallow Mercury, Venus, and possibly Earth. Don't worry though. 5 billion years is so far away that humanity has way bigger problems to solve first. Speaking of problems, let's go meet the planet that's basically the solar system's punching bag: Mercury. Mercury is the planet everyone forgets exists. It's like the friend in the group chat who never gets tagged. But Mercury has one of the wildest personality contradictions in the entire solar system. It is the closest planet to the sun, and yet it is not the hottest planet. That title actually goes to Venus, and we'll get to why in a second. But here's what makes Mercury wild on its own. Mercury has basically no atmosphere, like almost none. And because of that, it cannot trap heat or distribute it. So during the day, temperatures on Mercury can hit 430 degrees Celsius. Hot enough to melt lead, hot enough to melt zinc, hot enough to literally melt some metals on a kitchen counter. But at night, temperatures crash to minus 180 degrees Celsius. That's a swing of over 600 degrees Celsius between day and night on the same planet. Imagine getting third-degree burns in the morning and frostbite by dinner. Mercury doesn't have weather. Mercury has mood swings. Here's another mind-bender. Mercury has the most eccentric, meaning egg-shaped, orbit of any planet. And because of how slowly it rotates compared to how fast it orbits the sun, a single day on Mercury, sunrise to sunrise, lasts about 176 Earth days. But a year on Mercury, one full trip around the sun only takes 88 Earth days. Let that sink in. On Mercury, a single day is longer than 2 of its years. If you were born on Mercury, you could have your birthday party before you even saw the sunset for the first time. And despite being scorched on one side, scientists have found something genuinely shocking. There's water ice hiding in permanently shadowed craters near Mercury's poles. Some spots on this planet never receive direct sunlight, ever, because of how Mercury's axis is tilted, basically zero tilt. So those crater floors stay locked in eternal darkness and cold, even while the rest of the planet is an oven. So Mercury is basically hellfire on one side, ancient frozen ice on the other, and a calendar that makes absolutely no sense. And honestly, Mercury is the smallest planet in our solar system, smaller than Jupiter's moon, Ganymede, and Saturn's moon Titan. Two moons in our solar system are bigger than an entire planet. Mercury is basically that one guy who's technically older than everyone in the group, but somehow still gets carded everywhere. Let's move next door, to the planet that looks like Earth's twin, and is actually a straight-up nightmare. Okay, Venus. Let's talk about Venus. From a distance, Venus is gorgeous. It's the brightest object in our night sky after the moon. Ancient civilizations literally worshipped it. People call it the evening star and the morning star. Romantic stuff, right? Venus is also the closest thing to actual hell that we know exists in the solar system. Here's why. Venus is covered in a thick atmosphere made almost entirely of carbon dioxide, with clouds of sulfuric acid. Yes, the stuff that can dissolve metal, floating in its upper atmosphere. This creates the most extreme greenhouse effect of any planet. Sunlight gets in, but the heat can't escape. It just builds and builds and builds. The result? The surface of Venus sits at a constant 465 degrees Celsius. Not during the day, not in summer, constantly, forever, everywhere on the planet. It doesn't matter if it's night on Venus, it's still 465 degrees Celsius. There is no relief that's hot enough to melt a lead, tin, and zinc. If you somehow stood on Venus's surface in a normal spacesuit, you wouldn't just feel hot, your suit would liquefy around you in seconds. But the heat isn't even the scariest part. The pressure is. The atmospheric pressure on Venus's surface is about 92 times that of Earth's. To put that in perspective, that's similar to the pressure you'd experience nearly 1 kilometer underwater on Earth, the kind of pressure that would crush a submarine. So if heat doesn't kill you and acid clouds don't kill you, the pressure alone would crush you like a soda can under a truck tire. We've actually sent spacecraft to land on Venus. Soviet probes in the 1970s and 80s. The most successful one survived on the surface for about 2 hours before the heat and pressure destroyed it. 2 hours. That's the record. Now here's where it gets genuinely bizarre. Venus rotates backwards. Almost every planet in our solar system spins in the same direction it orbits the Sun, counterclockwise when viewed from above. Venus spins clockwise. Nobody knows for certain why. The leading theory is that billions of years ago, a massive collision with another object literally flipped Venus upside down, or slowed its spin so much that it appears to go backwards. And because of this slow, backwards rotation combined with its orbit, on Venus, the Sun rises in the west and sets in the east. And a single Venusian day, sunrise to sunrise, is actually longer than its entire year. So to recap, Venus is Earth's closest planetary neighbor, similar in size, similar in composition, and it is a crushing, acid-raining, 465-degree, upside-down hellscape where the sun rises in the wrong direction and a single day out lasts a year. And the scariest theory of all? Some scientists believe Venus might have once looked a lot like Earth, with oceans, a thinner atmosphere, maybe even more temperate conditions, billions of years ago, before a runaway greenhouse effect turned it into what it is now. Venus might be a warning. This is what happens sign, parked right next door. Okay, let's go home for a second. Let's talk about Earth. And trust me, even the planet you're standing on right now has secrets you don't know. You've seen Earth your whole life. You live here. So I'm not going to waste your time telling you it has oceans and continents. You know that. Instead, let's talk about the stuff that should be way more famous than it is. Fact 1. Earth is not a perfect sphere. Because Earth spins, it bulges slightly at the equator and is slightly flattened at the poles. It's technically shaped like an oblate spheroid, which is a fancy way of saying Earth is very slightly squished. Like a basketball someone sat on for a second and then got up. Fact 2. Earth's magnetic field is the reason you're alive. Deep inside Earth, there's a core of molten iron and nickel spinning and churning. This creates a massive magnetic field that extends thousands of kilometers into space, way past where you can see. This magnetic field is basically an invisible force field that deflects deadly solar radiation and cosmic rays away from the surface. Without it, the sun's solar wind would slowly strip away our atmosphere entirely, which is actually what scientists believe happened to Mars. So that aurora we mentioned earlier with the sun, that's literally the site of our planet's force field doing its job, glowing where charged particles get funneled toward the poles. Fact 3. The moon is doing way more than you think. The moon isn't just a rock that controls tides. Even though, yes, it does that. Its gravity pulls on Earth's oceans, creating high and low tides. But here's the thing nobody tells you. The moon also stabilizes Earth's tilt. Earth is tilted at about 23.5 degrees, and that tilt is why we have seasons. Without the moon's gravity holding that tilt steady, scientists believe Earth's axis could wobble chaotically over millions of years, leading to wild, unpredictable climate swings that would make stable, long-term evolution of complex life basically impossible. The moon might be one of the biggest reasons life as we know it could even develop here. And get this, the moon is moving away from Earth slowly, about 3.8 centimeters per year, roughly the rate your fingernails grow. And they'll keep doing it. In about 250 million years, scientists predict the continents will smash back together into a new supercontinent. So here's the wrap-up on Earth. You're on a slightly squished ball, floating in a razor-thin bubble of air, protected by an invisible magnetic force field generated by molten metal beneath your feet, kept stable by a moon that's slowly drifting away, sitting on plates that are rearranging the entire map of the world in extreme slow motion. And you're worried about your phone battery. Alright, let's go to the planet that everyone, and I mean everyone, NASA, SpaceX, sci-fi writers, is obsessed with. Mars. Mars. The red planet. The maybe we'll live there one day planet. The planet that's launched 1,000 Elon Musk tweets. Here's why Mars gets so much attention and why it's way weirder than people realize. Mars has the largest volcano in the entire solar system. It's called Olympus Mons, and it is almost 22 kilometers tall. That's nearly 2.5 times the height of Mount Everest. Its base is roughly the size of the state of Arizona, or about the size of France. Why is it so big? On Earth, volcanoes form over hotspots in the mantle. But because Earth's tectonic plates move, the volcano eventually moves away from the hotspot and a new one forms nearby. That's why Earth has chains of volcanic islands like Hawaii. Mars doesn't have moving tectonic plates, so the same hotspot just kept erupting in the same place for potentially hundreds of millions of years, building one single volcano into an absolute monster. And Mars also has Valles Marineris, a canyon system so large it would stretch across the entire continental United States. The Grand Canyon could fit inside one of its side branches and basically disappear. Now here's the part that gets people genuinely excited. Mars used to have liquid water. We have overwhelming evidence. Dried up riverbeds, mineral deposits that only form in water, ancient lake basins. That billions of years ago, Mars had rivers, lakes, and possibly even oceans. So what happened? Scientists believe Mars lost its magnetic field, similar to the one we talked about protecting Earth billions of years ago. Without that protection, The solar wind slowly stripped away Mars's atmosphere, particle by particle, over millions of years. As the atmosphere thinned, the planet couldn't retain heat or pressure, and the water either froze, got locked into the ground as ice, or was lost to space entirely. Mars is basically what Earth could become if we ever lost our magnetic field. It's not just the planet next door, it's a warning label. There's also Mars's two tiny lumpy moons, Phobos and Deimos, which scientists believe are likely captured asteroids, not real moons formed alongside the planet. Phobos is so close to Mars and orbiting so fast that it's actually spiraling inward, and in roughly 30 to 50 million years, it will either crash into Mars or get torn apart by gravity into a ring of debris. And here's a fun one for the dreamers. A day on Mars, called a sol, is about 24 hours and 39 minutes, almost identical to Earth. Mars also has seasons similar to Earth because it's tilted at almost the same angle. Out of every planet in the solar system, Mars is, weirdly, the one that feels most like a cousin to Earth, just colder, drier, and with way less air. The average temperature on Mars is about minus 63 degrees Celsius, and the atmosphere is so thin, less than 1% the pressure of Earth's, that liquid water on the surface today would either freeze or boil away almost instantly, sometimes both at once, depending on conditions. So yeah, Mars, home to the tallest mountain, the longest canyon, ancient rivers that vanished, a moon that's slowly falling apart, and possibly humanity's next home. No pressure, Mars. Now, between Mars and Jupiter, there's a region you've definitely heard of, but probably don't actually understand. Let's clear it up, because Hollywood has been lying to you. Quick myth-busting moment. In every space movie ever made, the asteroid belt is shown as this insanely crowded minefield where ships have to dodge boulders every 2 seconds. That is not even close to reality. The asteroid belt sits between Mars and Jupiter, and it contains millions of objects, but they are spread across such a massive volume of space that the average distance between asteroids is roughly 1 million kilometers. If you were actually flying through the asteroid belt, you'd probably not even see another asteroid without specifically aiming for one. Most spacecraft have passed through it without any special maneuvering at all. So what's actually in there? Most of the mass of the asteroid belt is concentrated in just a few large objects. The biggest one, Ceres, is actually classified as a dwarf planet. We'll come back to that category later. It matters. Ceres is so big that it's actually roughly spherical, unlike most asteroids, which are lumpy potato-shaped rocks. Scientists believe Ceres might even have a layer of water ice beneath its surface, possibly even a slushy ocean. The asteroid belt is essentially leftover construction material, the rubble that never got the chance to clump together into a full planet, mostly because Jupiter's massive gravity kept disrupting and scattering anything trying to form there, which is the perfect transition, because Jupiter doesn't just mess with asteroids. Jupiter messes with everything. Let's go meet the king. Okay, Jupiter. If the Sun is the dictator of the solar system, Jupiter is the bodyguard. Let's start with the size, because it's almost unfair. Jupiter is so massive that you could fit all of the other planets in the solar system combined inside it, with room left over. Its mass is about 2.5 times the mass of all the other planets put together. If Jupiter had been just slightly more massive, somewhere around 80 times its current mass, it could have actually started its own nuclear fusion and become a star. We genuinely almost had a second sun in our solar system. Jupiter is sometimes jokingly called a failed star, which is honestly kind of savage, but also kind of accurate. Now, the Great Red Spot. You've seen it, that giant reddish oval on Jupiter's surface. That's not a marking, that's a storm. Specifically, it's a massive anticyclonic storm, basically a hurricane that has been raging continuously for at least 350 years and possibly much longer. It's so large that 2 to 3 Earths could fit inside it. Wind speeds inside this storm can reach over 600 kilometers per hour, and it's been going for centuries with no sign of stopping. Though interestingly, scientists have observed it slowly shrinking over the past 100 plus years. Nobody knows for sure if it'll eventually disappear entirely. Here's another wild Jupiter fact. It has the shortest day of any planet in the solar system. Despite being the biggest planet by far, Jupiter spins so fast that a full rotation takes only about 10 hours. This insanely fast spin causes Jupiter to bulge noticeably at its equator. It's visibly squashed if you look at it carefully. Now let's talk about Jupiter's moons, because this is where things get genuinely sci-fi. Jupiter has over 90 known moons, but 4 of them, called the Galilean moons, Io, Europa, Ganymede, and Callisto, are absolute units on their own. Ganymede is the largest moon in the entire solar system, bigger than the planet Mercury. If Ganymede orbited the Sun instead of Jupiter, we'd probably call it a planet. Io is the most volcanically active body in the solar system, more volcanic than Earth. It's constantly being squeezed and stretched by Jupiter's massive gravity, generating so much internal heat that it has hundreds of active volcanoes, some shooting plumes of material hundreds of kilometers into space. But Europa is the one that makes scientists lose their minds. Europa is covered in a thick shell of ice, but underneath that ice, there is strong evidence of a liquid water ocean, possibly containing more water than all of Earth's oceans combined, despite Europa itself being smaller than our moon. And here's the part that gets researchers really excited. Deep beneath Earth's oceans, near volcanic vents on the seafloor where there's no sunlight at all, life still thrives. Entire ecosystems powered by chemical energy instead of sunlight. Europa's ocean floor might have similar volcanic vents, powered by the same gravitational squeezing that makes Io so volcanic. Which means Europa is one of the most promising places in the entire solar system to potentially find life that isn't on Earth. Not little green men, but maybe something, microbial life, something that exists in the dark under miles of ice, on a moon orbiting the biggest planet in our solar system. Jupiter isn't just the big one, it's a near star with a centuries-old storm bigger than our entire planet, a moon bigger than Mercury, the most volcanic body we know of, and an ice-covered ocean world that might harbor life. And we're not even at the prettiest planet yet. Saturn, the icon, the one everyone recognizes, even people with zero interest in space. Let's start with the obvious, the rings. Saturn's rings are made of countless particles of ice and rock, ranging from tiny grains of dust to chunks the size of houses. And here's the thing that surprises people. The rings are incredibly thin. Saturn's rings span up to 280,000 kilometers across. That's almost the distance between Earth and the Moon. But they're only about 10 meters to 1 kilometer thick in most places. If Saturn's rings were scaled down to the size of a sheet of paper, they'd be thinner than the paper itself. It's one of the flattest structures in the known universe. Now, here's something most people don't know. Saturn is the least dense planet in the solar system. Its average density is actually less than water. If you had a bathtub big enough, Saturn would float. I know that sounds like a joke, but it's a genuine real scientific fact. Saturn is mostly hydrogen and helium gas, with no solid surface to stand on at all. If you tried to land on Saturn, you'd just keep sinking through increasingly dense gas and eventually liquid until the pressure and temperature became unsurvivable. Saturn also has wild weather. Storms on Saturn can be absolutely enormous, and at its north pole, there's a bizarre, persistent hexagon-shaped jet stream, a six-sided storm pattern roughly 30,000 kilometers across. large enough to fit several Earths inside it. Scientists still don't fully understand why it's shaped like a perfect hexagon. And then there's Titan, Saturn's largest moon and honestly one of the strangest places in the solar system. Titan is the only moon in the solar system with a substantial atmosphere thicker than Earth's. It has weather, clouds, wind and, get this, rain, rivers, lakes, even seas. But it's not water, it's liquid methane and ethane. On Titan, the water cycle is replaced by a methane cycle. Liquid natural gas literally rains from the sky, flows into rivers and fills lakes at a frigid minus 179 degrees Celsius. Titan is so chemically rich and complex that some scientists describe it as a natural laboratory for the kind of chemistry that might have led to life on early Earth, just running on a completely different set of molecules in the deep cold. And there's also Enceladus, a small, icy moon that shoots geysers of water vapor and ice particles from its south pole out into space, fed by a liquid ocean underneath its icy shell, just like Europa. NASA's Cassini spacecraft actually flew through these geyser plumes and detected organic molecules, the building blocks of life, inside them. So Saturn isn't just the planet with rings, it's a planet so light it could float in a bathtub, with a hexagonal storm bigger than entire continents and not one but two moons that might be hiding life beneath their icy shells. We are now leaving the inner solar system for good. Everything from here on out is colder, darker, and stranger. Let's go meet the planet that's basically lying on its side. Okay, get the jokes out now. I'll wait. Okay, moving on. Uranus is often the most overlooked planet. And honestly, that's a little unfair because Uranus has one of the most genuinely bizarre features in the entire solar system. It's tilted on its side, completely. Every planet has some axial tilt. Earth's is about 23.5 degrees, which gives us seasons. Uranus's axial tilt is about 98 degrees. That means Uranus essentially rotates on its side, rolling around the sun like a ball instead of spinning like a top. Its poles point almost directly at the sun for part of its orbit. The leading theory? Billions of years ago, something, likely a massive object, maybe even an Earth-sized planet, slammed into Uranus with enough force to knock it completely sideways, and it's been tumbling through space like that ever since. This sideways tilt creates the most extreme seasons in the solar system. Because a year on Uranus takes about 84 Earth years, each pole experiences roughly 21 years of continuous sunlight, followed by 21 years of continuous darkness. Imagine being born into 21 years of darkness and not seeing a sunrise until you're old enough to vote. Uranus is also an ice giant, different from gas giants like Jupiter and Saturn. Beneath its atmosphere, Uranus is believed to contain a thick layer of icy materials, water, ammonia, and methane in exotic high-pressure states surrounding a rocky core. And here's a genuinely strange theory scientists take seriously. Deep inside Uranus and Neptune, the pressure and temperature might be extreme enough to literally rain diamonds. Carbon atoms under that kind of pressure can crystallize into diamond and sink toward the core, falling through layers of exotic ice like hail. Uranus also has rings, fainter and harder to see than Saturn's, discovered only in 1977, and a faint blue-green color caused by methane in its atmosphere, absorbing red light and reflecting blue and green back to us. So, a planet knocked completely sideways by an ancient collision, with seasons that last decades, possibly raining diamonds in its depths. Uranus deserved better marketing. Now, let's go to the edge, the last official planet, the one discovered using math before anyone ever actually saw it. Well, Neptune is the most distant planet from the Sun, and it's also got one of the best origin stories in astronomy. In the 1840s, astronomers noticed that Uranus's orbit was behaving strangely. It was being pulled slightly off its expected path, as if something was tugging on it gravitationally. Mathematicians used these irregularities to calculate where an unseen planet must be, and when astronomers pointed a telescope at that exact spot, there it was. Neptune was discovered through math before it was ever directly observed. Pure prediction, confirmed by observation. That's basically a cheat code for science. Neptune is famous for having the fastest winds in the solar system. Speeds have been recorded up to 2,100 kilometers per hour. That's faster than the speed of sound on Earth. For comparison, the strongest hurricanes on Earth top out around 300 kilometers per hour. Neptune's winds make our worst storms look like a gentle breeze. Despite being the farthest planet, Neptune still has internal heat. It radiates about 2.6 times more energy than it receives from the Sun, meaning something inside Neptune is generating heat on its own, likely from gravitational compression and possibly leftover heat from its formation billions of years ago. Neptune's largest moon, Triton, is one of the strangest moons in the solar system. It's the only large moon that orbits backwards relative to Neptune's rotation, which strongly suggests Triton wasn't originally Neptune's moon at all, but a captured object from the Kuiper belt, more on that in a second, that got caught by Neptune's gravity. Triton also has active geysers, nitrogen ice volcanoes that erupt and spray material across its surface, even at a bone-chilling minus 235 degrees Celsius, one of the coldest measured temperatures of any object in the solar system. And here's the thing about Triton. Because of its backward orbit is slowly decaying. In a few billion years, Triton is expected to either crash into Neptune or be torn apart by Neptune's gravity, possibly forming a ring system that could rival or even exceed Saturn's. Saturn might not always have the best rings in the solar system. Neptune might get an upgrade in about 3.6 billion years. So that's it, 8 planets, Mercury through Neptune. But our journey isn't over. There's a whole world of almost planets, icy leftovers, and one region so mysterious it represents the literal edge of where the sun's influence ends. So yeah, that's our solar system. 1 star, 8 planets, hundreds of moons, rings made of ice thinner than paper, oceans hidden under miles of ice, a volcano taller than 3 Mount Everest, diamonds raining inside a planet tipped over on its side, and an edge so far away our fastest spacecraft won't reach it for tens of thousands of years. And it's all just home. If this blew your mind even a little bit, let me know in the comments which fact actually made you say, "Wait, what?" out loud. I read every single one, and honestly, some of you are gonna have better facts than I do. Hit subscribe if you want part 2. Because trust me, we didn't even get to black holes, the multiverse, or what's actually waiting for us if we ever leave this solar system. That video is coming, and you do not want to miss it. Until then, go outside tonight if you can, look up, and remember, everything you just heard about is up there, right now, while you're reading this. See you in the next one.